Hi, Tor Lacey here. I am going to give you a quick tutorial on how to do the earthquake waves and epicenter location exercise within this animation. I click on that and we'll have an opportunity to listen to an introduction here.
Earthquakes and associated hazards.
I expect you to do that. I'm going to jump over to the
An earthquake
interactivity
has shaken
now.
the Central East region of the United States. 12 cities recorded the shaking on their seismometers. Use the recorded seismogram data to find the earthquake's epicenter and magnitude.
So here I'm going to choose 3 cities. So we have triangulation, which is needed to get the precise location of the epicenter. It's good if you choose 3 cities that are going to form a triangle. So I'm going to pick, let's say, Tulsa, which has just been highlighted here. I'm going to go across. How about Charlotte? And then I will choose Indianapolis. So think of this being a triangle here. I'm going to accept
Click
that.
on your chosen cities to study each of their seismograms.
I'm instructed to choose the city.
Drag the green line to calculate the length of time between the arrival of the P wave and the S wave.
And then analyze the seismogram record. What I'm going to do specifically is get the lag time, the difference in arrival time between the P wave and the S wave. And one reason that I'm doing this is it's not really that clear on some of these which the P, S, and surface waves are. But just as a review for this one, the P wave arrives when the baseline, which is totally flat here, begins to show amplitude. And this is the earthquake beginning, or the seismograph beginning to pick up the earthquake. So those would be the P waves, then the S waves, which have a greater amplitude, and then finally the surface waves, which have the greatest amplitude. We don't need to worry about those for determining the epicenter. What we need to know is the lag time. So I will grab this green line, this dark green line, and I'm going to move it from the beginning of the P wave right there where my pointer is pointing over to the beginning of the S wave, which is about right there. Move it back a smidge, and I'll accept that. Now I'm going to Charlotte.
Drag the green line to calculate the length of
P wave here,
between the arrival of the P wave
S wave here. So the green line starts at the P wave when the P wave first arrives at the seismograph. And then I'm going to drag it over to where the S wave first arrives. And I'm going to accept that. Then finally, Indianapolis.
Drag the green line to calculate the length of
Same
time
situation
between the
here.
arrival of the P wave and the S wave.
And I'm going to bring it to there. So that being the P wave, this being the S wave, and those are the surface waves there. So that looks pretty good. I'm going to accept that.
Establish the length of time between the arrival of the P wave and the S wave.
Next, we go to the travel time curve.
That is equal to the SP time difference.
The travel time curve or travel time graph plots distance versus lag time for the velocity of the P wave and the velocity of the S wave. Over here, I have these 3 dots, which are color-coded to represent the cities on the left. So the red one is for Tulsa. My SP interval, also known as the lag time, is 62. So I'm going to drag this up to 62. Charlotte, 88. Go up to 88. And Indianapolis, 52. Accept.
Click and drag each SP line so that its upper bound lies on the S-axis line and its lower bound lies on the P-axis line.
So I'm dragging this over So it fits just between the two travel time curves for the P and the S wave. Remember that the lag time is the difference in time between the P wave and the S wave. And my y-axis here is time. So this is the difference in time between the P wave and the S wave. There's a greater lag time at the Charlotte seismograph, so that line and lag time is longer. Move it over a little bit more, try to be as precise as possible. And Indianapolis has the smallest lag time. Okay.
Now that you have found the
Now we're going to
distances
find
to
the
the
distance.
epicenter for each seismic station, let's plot these distances on the map.
Okay, so we simply drop down. It's doing it for us automatically, and that gives us the distances. So I'm going back to the map. Notice that this is flashing green here, so I click on
your
that.
chosen cities and drag a circle of the determined distance to the epicenter around your
And
city.
as you should know from the reading in the lecture,
should have the same radius
in order
as the
to
distance to the
pinpoint
epicenter found
the
on the travel time curve in kilometers.
the epicenter, we need to plot a distance from the seismograph, but we are going to consider all possible directions because at this point we don't know from which direction the earthquake came. We only know how far away the epicenter was. So it is 560 kilometers away from that seismograph, km per kilometers, and I've stretched it out to 560. I'm going to go to Charlotte now. Click on the red flashing dot. And go to 795 there. Okay, and that's looking good because now these two circles are touching each other. Now Indianapolis.
If your measurements are correct, your three circles should exactly
clicked too
or
quickly there.
on the same
I'm going to
point.
470.
That is the location.
And
if
there
your
we go.
measurements are correct, your three circles should exactly or nearly intersect on the same point of the map. That is the location.
So this is decent, but not great. So I could go back and fine tune my lag times, because ideally this circle would go out just a little bit further, but this is pretty close. Okay, so I would say that's kind of just barely good enough. So I'm going to accept that.
Now that you have found the epicenter, it is time to calculate the magnitude.
So now we're going to calculate the magnitude.
Click continue to proceed.
I'm going to click continue.
To determine the highest amplitude of ground motion recorded.
In order to get the magnitude,
the highest peak of the highest amplitude recorded on this seismometer.
We're going to measure the highest amplitude recorded on the seismogram here. So I'm going to bring that line up to the very top of that tallest peak, hit accept, and then do it again for the other seismograph stations.
Drag the black line to the highest peak of the highest amplitude recorded on this seismometer.
Accept, and then do this.
Drag the black line to the highest peak of the highest amplitude recorded on this.
Accept. Now I'm going to click magnitude. It's flashing green here.
For each seismic station, place the points on the highest amplitude measured and the corresponding distance to the epicenter for that seismic station.
So at the top here it says amplitude
intersect near the same value
in millimeters, and then at the bottom here it says distance to epicenter in kilometers, and then you've got your kilometers there. So let's start with the Tulsa one here. Tulsa has an amplitude, or we measured an amplitude of 3 millimeters, and based on our lag time, that seismograph station is 560 kilometers from the epicenter. Now the scale here is a little bit funky and not the easiest to read, so you have to make a bit of an estimation. That's 500 there, 700 there. We're looking for 560. I assume this is 600 here, so I'm going to put 560 there. Now for Charlotte, 795. So there's 700. That's probably 800 right there, so it's going to be more or less there. It has a millimeter of 1, or it had an amplitude of 1 millimeter. And then Indianapolis had a amplitude of 6 millimeters on the seismogram and is 470, again, I'm estimating here, kilometers from the epicenter. Checking my work here. Let's see, like that to go over a little bit more. Yeah, let's see, that's 800, 900. Yeah, maybe I didn't go quite enough there. Okay, that's looking pretty good there. So now we see all the circles more or less intersect right there. That means the magnitude was 5.5.
Your lines should roughly intersect on our magnitude
So what
scale
you
line.
are going to do is
don't have to
go through
intersect
these
perfectly.
same steps,
The value of the magnitude
but
of the earthquake
you
is
will
close to this point of
choose
intersection.
3 different seismograph localities. I don't want you to use the same combination I did. If you use one of the same cities, that's okay, but choose at least two other different ones, or 3 different ones altogether. And I'd like you to take 2 screenshots to show me that you did the work. One screenshot of the magnitude calculation, and then one screenshot of your epicenter plotted on the map. I can't go back to that now, but when you're there, screenshot the map showing the epicenter and screenshot the magnitude calculation as we see here on the screen. All right, I hope that was helpful for you, and good luck with this.